Okay, let's get started. Today we are going to go over chapter 6 on the function. Okay, function. So function basically is similar to Java. There's only two things I would like to talk about function today. Okay, two things I would like to talk about function today. Basically, function is the same. It's actually a module. You can reuse the call, and then someone can call the function. And then you can get the return result. Okay, this one the same, and they are user-defined function and library function. Okay, these are the same. Okay, so you have a function and the parameter, and then sometimes you write a function prototype with a semicolon right here. So you don't implement it. Sometimes you don't implement before your function. So to tell people that what the function is, okay, what the function is. So let's look at this one, though. Let's look at this one. This one a little bit different from Java. Benjamin, can you say something? I did not hear you.
Oh, no, I didn't say anything.
Hello? Can you say something?
Yeah, yeah, is my mic not working?
Hello?
I'm
Can you
saying
say something? I just want to make sure your microphone is working.
test.
Hear me? Can you say something?
Test. Yeah, it's working. I can't hear him at all. You can no.
Hello, Benjamin, can you say something?
I
I don't hear you.
my microphone's fine.
Let me check, okay? Let me check. So it's working. Oh, we actually go to the wrong one. Let me see. Can you say something now?
Yeah.
Okay, that's my problem. That's my problem.
Yeah, no worries.
Actually, it's my room problem. Okay, my room set to the wrong setting.
Okay.
I think you keep talking. It's okay. Sorry, it's my own setup.
Yeah.
But it's okay. We are trying to make sure we are working. Okay.
Yeah.
Okay, so the function may have a prototype. Let's look at this one. This one is very important. Okay. So let's assume that we actually have a simple function called square. Okay, let's define a function right here. It's actually integer square integer x, and you return x times x. Okay, this is a very simple function. And right here we have integer a equals 3, and then integer b equals square of a, and then print f. Okay, let's assume that we got these. And it doesn't work. It doesn't work because C language, you cannot have the function defined after main function. So main function is a function that you run, but before you actually see this square, you do not have a definition of a square. Square right here, no definition of a square. So this is not okay. You need to put this one before here. That would work. So this is different from Java. Java, the location doesn't matter, but here C language, it do matter. Where you put your function, it does matter. So this it actually work, right? This should work. Now let's actually put it back. So if I still insist that I would put this square right here, how can I avoid the compilation problem? You can avoid the compilation problem right here. You put this prototype of the function right here. And this variable name not needed, you just need a type. Is that okay?
Yeah.
So you can declare the function before it, but you actually do not implement it. This is called unimplemented function. Unimplemented function, the purpose is to tell compiler that, hey, I have a square function, take the integer input and providing the integer output, then you can use. But the definition actually is after my main function. That actually is fine. Okay, that actually is fine. So in this way, it will work. Okay, and it's different. This is different from the so-called Java. Okay, Java doesn't need this. Java doesn't. That is Java's order of the function doesn't matter. Okay, but here we do matter. So usually, this one it is not written in this way. It's actually usually then we would have a something called square.h. The h file to do if undefined square underline h and define square underline h and then end the if. And then you put this kind of the prototype there. This is .h file. Okay, .h file, the header file. Save. And in your main program right here, that's actually include. So basically, all of your .h file or your function prototype you put in the .h right here, it will work. So let's try another one. Let's actually try, how about my function integer cube? And then go back to here. Let's actually also define integer cube. Okay, and then the C function right here, we actually do copy the integer C equals cube. Okay, cube of A and plus C. Okay, and then this is fine. That's wrong. Okay, cube is 27. So this is the way that you want. Another way you can handle your header function put a header function in the .h files, put these different function prototype in there, and your main function using include .h, okay? Then your predefined function can all be in there. Then you won't have problem of the program order anymore. Okay, so that's the idea of putting the so-called prototype function of the function. So these are different function. They are similar. Okay, I don't. Now this one. Okay, inline function. Let's talk about inline function later. Let's talk about something else now. What you call in and out. Okay, in and out of C. Now, okay. Now, let's assume that I have a number A, okay, and then I would like to read some from keyboard with some value and put it into my A variable. Okay, I would like to read some and update my A variable. So A need to be updated, so I need to call a function called read. You can read and then you actually pass the A variable there, but this one will not solve the problem because okay, let's assume that we write this function. We have A variable set preset to be 5, okay, and then we read A. Suppose we read A should update A and then we print A. And then we're using this function that we write is called reading A X variable. So you will enter A and then enter A and then update the X value. So this one you run it, but you will update only this X. You will not update A here. Okay, that's the problem. So it doesn't update, it doesn't change the value of A because I will explain it, okay? Because, I'm sorry, you cannot run in this one. You have to run this one. Let's quit it, okay? Let's quit this one. Actually, I use the wrong and turn the output part, close it. Okay, let's close the output. Still not, let's actually quit it, okay? Quit and enter one more time. So you will read A that's typed in 10, but the A still be 5. So read A apparently does not change the value of A. It's only, okay, so this one you actually have an A that's actually 5. Your function read have a parameter X. So you copy the value of 5 over here. And then your scanner would read for the variable of the X. So you update this one to 10. But your A is not changing. So you actually still will return 5. So this one is a input only function. The X is only input only. Now, let's write another function. This one called reading. This one is in and out function. So I put a star right here. Okay, this is called in and out function. Now, here I say reading alias of A, address of A, and I'm going to print A. Okay? So the difference is this one is input only because you take the variable's value and then you will update this local variable right here. Okay, this one you read in as a pointer. So what will happen is right here you have A equals 5, okay? And then right here you have a X pointer. So X pointer, X is a pointer. So you put in A4 to B4 here, the address of A to B4 here. So X is pointing to this A right here. Okay, so when you print, it'll print the body of this pointer. Body of this pointer is this pointer pointing to here. So you print 5. And then X value will be reading for X. Here you don't need to put the address. No, you don't need to put the address because you are updating the variable that you pointing to. This one got updated to 10. And in this way, you can update the variable right here. This become an in and out variable. So this is the input only variable. This is a in and out variable. An in and out variable is a pointer. Okay, in and out variable is a pointer.
Yeah.
So by doing this, okay, you have to know about this. Okay, let's save it. So here let's do GCC in and out. Let's see dash O in and out. In and out. So you enter A, let's enter 10. it's still 5, it no change. It currently is still 5 because the A is just updating your local variable, okay, your parameter variable. Now, let me put a 10 right here, and then this reading function will update it to 10 because of this in and out feature. Okay?
Yeah.
Okay, so this one is a in and out feature. Okay. This is very important, okay? In Java, you don't have this. Java, you only allow this one. Okay. Now let's actually look at another one. Let's look at collection, the C. Okay, what is collection, the C? Let's look at it. Right here, I have an integer A array of 3 elements that is equal to 1, 2, 3. Okay. And then I have void print integer A array. A is an array. And then I need to put in the length for it. So length, and then for integer I equals 0, I less than length, I increase. Then print F. Okay, so this one you have an array and then you read and print it. So you do print. Okay, I'm sorry. Let's actually call it print array. Okay, so A is a 3-element array, and you print A and then for length of 3. Okay. You run it, you got a 1, 2, 3, there's no problem, okay? You got 3 elements without 1, 2, 3, there's no problem. This one is okay. So what'll happen is right here, when you pass the value right here, you do have a array of 3 elements. You put 1, 2, 3 right here, okay? That's in your print array function. And then you run it. Okay, now let's try this one. Let's try. So I have another function called update array. An update array would actually set the value to be 100, 200, 300 instead of 1, 2, 3. After that, let me print the array one more time. So when I print, will I get 100, 200, 300, or will I get 1, 2, 3?
Um, hey. Wait, can I see print array again? Hmm. Would print 100, 200, 300.
Hmm?
It would print 100, 200, 300.
Let's try, okay? Yes, it's 100, 300, 300, okay?
Okay.
But here, let's try put a 3. Then what will happen?
So, I mean, I would say no change, right? It's just the same, it's still the same length. Hmm.
Still the
Yeah.
same, okay? So this one, what happened is like this A, you have an A, you have 3 value over here, okay? 1, 2, 3. So when you pass to this function right here, this A, no matter is ADs or ADs, it doesn't store the value, it doesn't copy 1, 2, 3 over here. It actually is, storing the ages of 451A. Let's put 451A. And it's pointing to here. So A of 0 update to 100, you change this one to 200, change this one to 300. So A of these actually it doesn't matter, okay? Now, if I don't change it this way, I actually do pointer. I still get the same thing.
Yeah.
So here you put ADs or star A or ADs. Effectively, it's all the same. They just pass the address to the array. Is that okay?
Yeah.
Okay, now let's try another one. This one is collection number 1. Let's try passing a structure. So this time, Okay, I define the so-called structure point as a point. So point is the new type. Okay, point to 2 by, but this new type is actually this is structure type. Okay, we are going to work on this one, and then we have a point A equals 2 and 3. Okay, 1 point. Let's call it A1. Point A2 equals 3 minus 4. Okay, let's do this. Now let me have a void print point. Here I have a point X. Let's actually don't call it P, okay? Don't call it X, let's call it P. Don't call it X, call it P, okay? So this one will print now the point. Okay, so you have a point P, actually point A1 and A2. And you would like to print the value of these two. There's no problem, okay? This is point P, and then you try to print it, there's no problem. Let's actually save it. So that's this one called GCC structure. Return 0. Oh, I made a mistake. Okay, so you print out these two values. That's no problem. Now, we may want to update point P with integer x, xx, integer yy, okay. Then your p dot x equals xx, p dot y equals yy. Okay. Okay, question. Will A1 be updated or not? Let's take out this A2. So only A1 now. So will A1 be updated or not? Will it be 2, 3 or become 10, 20?
I think it will. Feels weird.
It's still 2, 3.
Yeah, it doesn't update. Yeah.
It doesn't update. Why it doesn't update?
Is it because of the XX and YY?
Because when you call this one or call this one, the function doesn't really pass the address of the P there. It actually passes the value of it. So your A1 is 2, 3. P copy the 2, 3, so it's 2, 3 right here, and then you later update it with SS and YY is 10, 20 got updated. It will be the same, will be this. So A1 will not be changed. Okay, that's because this one actually is a input only function that cannot update a P. So if you want to update a P right here, you have to use the in and out variable. So let's do pointer version. And then if the way the X you pointing to got updated, the data that pointing to got updated. So this one, P is an in and out variable now. It can be updated, it can pre-printed. So right here, you cannot pass this, you have to pass the address of A being passed, because right here is a pointer. And it got updated. Okay, this one, I demonstrate the idea of what is a in and out variable using the pointer. Okay.
Yeah.
So be careful when you pass the array and you pass the structure, the result is a little bit different. Okay. You have to make sure you understand what got passed to the function. Okay.
Okay.
Okay. That actually is what we want to say today. The functions, one important feature we would like to have. Okay.
Yeah.
This one is a inline function. Okay. Inline function. The inline function actually is a function, but it will automatically call the function at the location, so it will perform faster. It will perform faster if you have a inline function. Okay. That's purely for the performance issue, but nowadays people tend not to use it because of the simplicity of the program. Okay.
Yeah.
The purpose of this one is to make sure that your performance is better, because you actually will call the function right at the location. Okay, that's called inline function. So inline function is a combination of macro and function. At the time of the declaration and definition, function is preceded with inline, and function code involve involve execution time overhead. An inline function reduces the function overhead. You do not need to call from a function, jump to another one and come back. Okay, it will be reducing the function call overhead. So the advantage is that make the program faster. Okay. So let's see. Here you have a step inline function. What happens is that usually your function, if you don't have an inline, you just have these. You will come to here and jump to here and then come back. And then return and come back. Okay. And then you have the function call and then return to the function here. If you do inline function, what happens is right here, you do not actually jump. You copy the code to here right away. Does that make sense?
Yeah.
You copy the code to here right away. You don't actually do function transfer. So let's do this one. Okay, let's do this one. This one, pretty simple. Let's create another one called square number 2.c. Okay, square number 2.c, because we want to write a program very similar to square for ourselves. So right here we do static inline. Okay, let's actually write this. You have integer square integer x. That's the original square function you write. Okay, that's the original function, that square that you write. Let's try to be the same as the previous one that we have, okay? Okay, so this is the same as the previous one. Originally it's like this, and we do GCC square 2 c dash O square 2. And then we run square 2. Okay, no problem, you get the same result. But right here, we would actually put static inline just to tell the compiler is static inline. So what happened is, here instead of jumping to the function and come back, it will, when you call it, it will actually copy this x squared to put the x times x right here. Okay? It will be faster. Directly put the x times x right there. It will be faster. So let's copy one more time. Change it to cube. Okay, so this one, we change it to cube. Suppose square and cube would jump to the, do not jump to the location, you will actually replace your code right away, right here, okay? Okay, let's call inline function. In reality, the use of the inline function and function basically no much change. Okay, no much change. It's actually using just like a function, except that it is faster. Okay.
Yeah.
Next one is macro function. Macro function is different from inline function. Inline function is you replace by the execution code. Macro function is you actually do what? You do macro replacement. Before your function call, you will actually replace it. Okay, you will actually replace it. So what happened right here is, let's try it. Okay, let's try to define the macro function. So let's define something called square 3. So this is yet another way to write this kind of a function. Let's copy everything and put it into my square 3. So instead of writing this, we write this. We write define square of the x and y as x times x. I'm sorry. Square of x as x times x. And then define cube of x as x times x times x. So what happened right here is like, this is macro definition. Macro definition means that when you see a square of x, this one will be used as the text, not even compilation. You will directly replace this square x as s times x. So what the compiler see is just c x times x right here. Just c x times x right here. Okay? It's called macro function. The same. So what I want to say is a function, inline function, macro function, they deliver the same result.
Yeah.
It said that the way that we replace the code is different. One is jump to the function code to call it. The other one is put in the execution code to your execution location right away. Another one is just do text replacement. Okay? Three way of handling the function are different, but you can define the function totally in different way. Okay? So right here, we do have an example of defining the so-called maximum function. So maximum function, this one change like mark. If you have more than one line, you will change that. So basically, you will do macro AP, you will do conditional statement. Okay, convert A to a certain type of A, and then certain type of B are two variable. Okay, and then you do return the result of conditional statements. So you will actually see this function, this whole thing will be put right here to replace the code. Okay. And anyway, you will perform as the maximum function. Okay. How about this? How about let's type it out? Okay. Mac C the C. Okay, now the problem now is how to define this mac function. Okay, so it's define max of x and y. You change line, that's more than the line. Right here, you write this. You write parentheses. Okay, and then you write curly brace, curly brace. Okay, right here you write type of x, underline x equals x. Declare two variable. Okay, no matter what type of the x is. Okay. And then this is more than a line. So right here we do change line mark, change line mark. This one we merge into one line. And then change one line mark. Okay. And this will work. So a little bit difficult to use anyway, but this is how you define the macro function in multiple line. Okay. A little bit not as easy to use like a function call. So we don't recommend it. Okay, we do not recommend it. Okay, any question?
No.
So today we go over the function and we go over the input output function and we go over the inline function. We go over the so-called macro function and we go over multiple line macro function. Okay, so far that's what we talk about today. Function as a task, function as a mathematical function. I think this one okay. Okay, function as logical condition, that's fine. We all know it. Okay. Header file. Header file will cover the header file already. Okay, later, external reference later. Now let's talk about one more thing. Function as a parameter. We still have the square function, we still have the cube function, okay?
Yeah.
Okay, but I write a function called run function. run function will run and apply the function of the f function to the x parameter. Okay.
Okay.
Let me see. Let me change it to only f. Okay. So this is wrong. I do not see it. A value or void type. Oh, that's the problem right here. It's not. That's not a function error. That's actually is this one. Okay, let's copy it one more time. Now I pass the function of cube to there as well. Okay, so there are two functions. Serve three function. The serve function is passing a function as parameter. And then there's a variable parameter as well. Okay, the variable parameter is your variable of the x, the value you would like to run, and you apply this function to the value. Okay, so that's the run function. So run function will apply square to a, apply cube to a. And this is the way you declare a function of integer, a function of return integer type. Okay. It doesn't change. It doesn't change because here I did not change it for C. I'm sorry. Okay. Is yet another way to write this square and cube function, not macro, not that actually is a functional programming. This we call it functional programming. We call it higher order function, or sometimes we call it functional programming, or passing function as parameter. So C language allow functional programming. Okay, that's what we want to say. C as a very old language, but it already support a functional programming. Higher order function is allowed to be passed. Java doesn't allow it. Okay, Java know this. Okay, so that is another way to pass the function there. Next one we are going to call external reference, external keyword and static keyword. We are going to talk about the static keyword and external keyword now, okay?
Yeah.
Now, let's try this. Okay, let's have a three program. One is called A.C, the other one is called B.C, and then is the third one called main.C. Three different program, okay? So now in our main program, let's see, A program. Let's put our good friend there. So our square function put into A.C, okay? B.C, let's put our cube function there, okay? Okay, so we do have A.C, B.C putting together. Now let's actually go to the main.C. Main.C is the main program.
这个太简单了，你记得有那小刀片儿的，你当了都行，这个指甲都是这样，这为多，不粘的。
Now, so this one is still the cube and square function, okay? So that's actually, let me copy from squares 2, okay? It will be faster. Just copy this to my main.C. So I'm supposed to run my square function and from A.C, my cube function from my B.C, right? In my main function. And I roll this. And to compile it, let's call, actually, let's call run main.bat. Okay, run main.bat. So you will do gcc A.C, B.C, main.C -o go main, okay, and then we'll go main function, okay? Any question?
No.
No, we will save. Then we will run main.bat file. What happened is your main function do not see the square and cube. Your main function do not see the square and cube. That's very easy to understand because nobody tell them there's a square and cube to use, even though they are written in A.C and B.C, right? So it doesn't work. It's actually okay. It doesn't work. We know it won't work. So what will happen is that you need to write the A.H and you need to write B.H. So in eta h, you put in this.
那就背点儿给起，对不起，我们上班的时候是吧？二几刷就这样。
Okay. In beta h, you put in this.
这个拿老上去。
So you tell people what is available in A dash C and B dash C, and then go to your main function right here. That's actually to include A dash H and include V dash H. And reference to square. You still don't see it, okay? You still don't see it. You still don't see it. So right here, let's type this. Here a compiler that we do have the external function from different module coming in for integer x and integer square and cube. Okay. It still have an undefined square. Let me see. I think it's different issue. Oh, I have a spelling error. That's why. So let me take out this 2h is not needed. One more time, okay? One more time. Okay, this time it worked. Okay?
Yeah.
So what happened is that your eta C do have square function in eta C, and then you have a header, you put a square of something that you can use. And also you put a cube in the beta C, and you had an implementation of this cube dash C right here. And your main program do include these two .h file, and then you can run these two programs. Okay. Now, when you see the variable called external and static, this word external means public. Static means private. Okay. So right here, if I don't write anything, my square function, I don't write anything. These and this is the same. You write it as external. You write it as external. You write it as external or no external is the same. It just means public. It just means public. So those two functions are public. You still get the same result, okay? No matter it's external or not external. So this one just means public. So what you would do is you have a a.h and you do external square. That means this square function is a public function. Public what? Public, you have the square here. This public one will be shared by different module. Other module can call it. Is that okay?
Yeah.
A little bit like C, Java language. This is the so-called square a.c is a square function module. Is a class, and then you say it's external means it's public. Public, so then other module can call it. Okay. So now if I actually go to my main function right here, okay, and my .h file right here, I don't call it external. Let me take it out. Let me call it static. And my function here, I call it static. If I call it static, this function become a private function. Only the same function in the a.c will see it. In main.c will not see it. Then let's see what happens. You fail.
Yeah.
Okay? So that means you will need it. You need to declare it as a public. Okay? And you get it. So what happened is you write the external or no external is okay. As long as the function will be public. Okay, function will be public. Now let's see. How about if my main function here, I declare a integer big number. I don't write it here, okay? And then right here, I actually do nothing, okay? Do nothing. My function, if I do nothing, it will be an external function. I write it or not writing it, it's an external function. And right here, go to my main function. May I print f my big number? May I do this? No, because I don't see it. Because this one, as you see, I don't see it. This big number is not shared. So what you will do is you say, let me share my integer big number. So okay. And your main function already included right here. So you will see, so this one, you do wrong main. it doesn't see the main function, main variable, that's okay. You go to this one, you have to declare it as external right here as well. Be consistent, okay? I'm sorry, I actually need to be consistent. Okay, be consistent. Okay, then the main function C. Any question?
No.
So this variable is a share variable, okay? Share variable right here, if you do print it right here. It will still work, okay? It will still work. Anyway, let me take this one now. What I would like to say is, if you want to share a variable, you need to make it as an external variable. External variable is a public variable. Okay, it's a public variable. Right here, if I say static integer small number, and then here I have a static integer small number right here. I go to my main. This one, I do print the same number, small number. Okay, it won't work because static means private. Private means only A.C will see it. Your B.C, your main.C, even though you include it, but you cannot run it because it's a private variable in the A.C module. You got 0, you are wrong. Okay? Does that make sense?
Yeah.
That doesn't work. That doesn't work. So I keep it there. Okay, this one doesn't work. Okay. What I want to say is these words, external means public. Public means different module can use it. Okay. And then static means private. Private means other module won't see it. Here you try to print it, you still can print it, but you print the wrong number. The number I set should be minus 9999. It's not 0. Okay, it's not 0. It shouldn't be like that. Okay. So external variable is a shared public variable. External function is a shared public function. Static variable is a private variable. Static function is a private function. And then if you don't write external, don't write static, variable will be static, and that will be private. function, you don't write it, you don't write the external, it will always be external. It will always be public. Is okay? So this follow the private data public function rule. That is the so-called what? Private data public function. That's the so-called encapsulation. This is so-called encapsulation in Java. Okay. So C language enforce the so-called encapsulation right here. Okay. Doing something like that. Here we show you the share variable and the public variable right here. Okay. Share function, share numbers, and private data like other module won't see it. Okay, we talk about this. Any questions so far?
No.
No? Now let's actually work on another one. Okay. Let's have the algorithm program. So this one is the typical linear search function. You give me an array and then for certain lengths, and then the key I will just search. So this one is a searching function. Okay. And then let's have another one called binary search. Okay, this one A need to be sorted already. We would have integer low equals 0, integer high equals length minus 1. Okay, and then while low less than high, less than equal to high, no crossover. Okay, go over integer need equals half of the low plus high. Okay, so this one is two function. It's searching function. Okay, searching function. And this is two searching function we would like other people to use. So we define something called algo that H. algorithm. Okay, algo means algorithm. Okay, right here we do, we want it to be shared, so it must be external. So external search. Integer A array, integer length, integer key. Okay, external integer binary search, integer A array, integer length, integer key. Okay, so these are what we would use as algo. Now let's have another module called data.c. Let's call it data.h. Or that data.c. So this data.c, let me have a external integer array, a array of 10. Okay. Let's call it data. Don't call it a. Okay, so data module have shared data. And then the algorithm has two shared algorithm. Okay. So it's algorithm, so then this one is combined function. So combine the C. So here I'm going to include algorithm.h include data.h. But here, one thing you need to know is that your data is external integer data of 10 is using the external one. Okay, you need to declare it. Let's don't declare it for the time being because your data.h already has it. Oracle.h, what happened? Oh, I have a typo. Let me change the name. Go back to my combine.c. Okay, I got this. Okay, so I do 2 linear search, 2 binary search. I got 4 index. So this one, I will try to teach you how to write program of multiple module, how to share data or keep it as a private data using external and static as the private and public specifier. Is that okay?
Yeah.
So far, okay? Then this one, let's go GCC combine, let's see, basically combine. Something wrong? Oh, no, that's H2 wrong combine dot BAT. Okay, I make it too short. Okay, so it's GCC data the C over the C combine the C basically combine and wrong combine. Okay, let's just save. Let's do long combine, long com, typo right here, 1 extra space. Long combine, long combine. Data initialized as external. Oh, this one don't do it. One more time, okay. Still get -1. Something wrong. External data. Let me see here, let's see. Combine the C. Let me put this one back. Oh, I'm sorry. This one I did not change before. I'm sorry. It's here. Okay. I'm sorry. So this one, let me comment it out. I keep printing out the index 1, so that's why it's always -1. Sorry. Okay, so you got it. This one we have is shared variable, shared data in data module. Okay. Any questions so far?
No.
Today we teach you different way of writing functions. Okay. So this is share public data and private data. So there are some other specifiers. So static and the external mean public and private. Okay, that actually is fine. But there are some more different kind of the variables. Let's see, function declaration. So this teach you how to write different module, okay? Compile together. External keyword, we talked about it already. So static is private data, okay? There's also auto and register. Register will store in the CPU's register, make it faster. So it is not like static or share, public or share. It actually is not in the memory. It's not, this kind of register variable is not in the memory chart. It's not in this data segment or dynamic data or in the stack. It doesn't in here. It actually is put into the register. Okay. So that's different memory model, but we don't cover it right here. Okay. So we teach you external for public, static for private. Okay. This one is register variable, and there's another one called auto. Auto is just like your stack variable, local variables. Okay, local variables. So these are different variable scope. Okay, passing value and passing reference for the so-called shared input and in-out variable. I already talked about it today. Okay, so we don't try to make it too complicated here. Just give you the idea of how to call the different functions variables today. And recursion, I think you are fine for recursion. Okay, recursive function, I think you're fine. It's the same as Java's recursion. Other than that, it's a function. I think we cover all of the things that we want to cover today. Okay. Any question?
No.
No, that's it for today. Today we basically talk about different type of the variable, input variable, output variable, in-out variable. Okay. Also talk about different type of the function in different modules. Share public variable, share public data, private function, or share function for external function, okay? Put it into different module and compile in multiple module, okay? These are what we learned today, okay?
Yeah.
Okay, next week we will go to array. Bye-bye.
Okay. Bye, Mr. Cho. Have a great day.